to the position I want to observe. So my name is Eric Stempels. I'm an astronomer at Uppsala University here. Astronomy is fascinating. It brings you into interesting discussions about what is time and how old is the universe, or even where do we live, what are we made of, are we alone, what will we see in the future, can we build instruments that can open up new areas of astronomy, can we look at new types of light, can we send instruments into space and measure things that are better measured from space than from the Earth. We are able to send even probes to other planets in our solar system. But because of the large distances, it will be very difficult for us to send anything to the nearest star. So we will have to continue sitting down and look at what nature throws at us. And we are now at the old Astronomen Observatory in Uppsala. This was a building which was built in the 1850s to replace an even older observatory in the center of town, because there was so much light and disturbance from traffic in the center that they decided to move the observatory very far out of the city, which meant in those times that it was placed about 1 kilometer from the city center. When it started, astronomy was still in its infancy in the terms of that observations were mainly to observe the positions of stars, determine the time, and give a reference. For example, for people in town, clockmakers often came to the observatory to set their clocks according to the time observed at the observatory. In the beginning of the 20th century, Professor Dunér introduced a spectrograph at the observatory, which meant that instead of measuring positions of stars, he also measured the quality and colors of the stars, and in particular, if there were any spectral lines, absorption lines in the light of the stars. This means that he was able to determine what the contents of the stars are, what kind of elements, what kind of compositions these stars had. And this then introduced astrophysics into astronomy. Why do stars burn? Why do they emit the light that they do emit? Do stars evolve? Where do the elements that we're all made of come from? Stars mainly burn hydrogen, but hydrogen is transformed in stars into more heavy elements. In fact, all the elements that we have around us, that we are made of, at one point were made in stars through the process of atomic fusion. So we are all products of stars. Later in the 1950s, 1960s, the focus of astronomy slowly shifted from stars also to galaxies and the universe. Galaxies are large collection of stars very far away that look like nebular objects, very faint and sometimes fuzzy objects. But by studying these over a long time, you can determine, for example, how time affects the universe, how galaxies and stars age, and also how the universe actually expands. The professor of astronomy himself lived in the building all the way until the 70s. This was not only an observatory where people came to work, but people actually lived their work in this place. In relation to these old observatories, time is a very important ingredient in astronomy. All the time measurements, even today, are somehow related to what happens in the skies. We essentially set our clocks to the rotation of the Earth and determine the dates of the year in relation to the seasons, which is dependent on the position of the Earth around the Sun. Even though that the sky looks like it's all filled with stars in fixed positions, if you look very carefully, you can see that stars move. These small movements reveal something about the inner workings of stars and stellar systems. Many stars come in pairs, in binaries, and when the stars move around each other, they make a motion, and this motion, by measuring the motion, and especially measuring the time it takes for a revolution in this motion, we can determine very accurately the mass of stars. And if we know the mass of stars, we can also infer things about their evolution, about how they live and how they develop. So time is an extremely important element in astronomy. We have observations of stars that go back not only just a few years, but centuries ago, that we know exactly at what point, for example, planets passed in front of the disk of our sun, or at what point planets passed very close to each other. By combining these observations, we can make a very long history of the movement of planets in our solar system, and in that sense determine the workings of our solar systems extremely accurately. There is no single quantity that is measured as good in astronomy as time, because we can have a time base of hundreds of years, and that's quite unique, even for other sciences. Time is used in instruments as a tool, because if you have light, and light comes in from the telescope, and you take part of the light and you let that light travel a longer distance, it will take time to travel that longer distance. And then by combining the light that travels the short distance and the long distance, you can very accurately determine what the light is composed of, what colors there are in the light, or better, even what colors are lacking. Because if light passes through a gas that has a certain temperature and a certain composition, the gas will remove some colors from that light. And then by combining this with this delay in light path, we can determine what this gas was actually made of. So time is still a very important tool to use even for modern instruments. Also for studying these stars that are binary, or nowadays even stars that have planets around them. What we can measure is, we can measure the position of a star. We cannot see the planet because it's too faint and too small. But the planet affects the star and moves the star slightly around. So it draws the star into this small orbit. This orbit we can see using our instruments. And then by looking very carefully, we can find out whether this was just one single planet that goes around the star, or maybe even many more. In this way we can find other systems around in the galaxy that have stars, have planets. And maybe some of these systems are similar to our solar systems. And some of these planets are in positions that make it possible to have liquid water on the surface, which is an important prerequisite for the existence of life. We talk about distance of hundreds of thousands to millions or to billions or even millions of billions of kilometers. These numbers are enormous and may be difficult to grasp. But working for a long time with astronomy, somehow you get used to the fact that things are far away. Just like a biologist is separated sometimes from its object by the sheer small size of the object. We are separated from our objects by the enormous distances. The only thing we can do is see and what nature throws at us in terms of light that comes to us and observe these. It's very difficult to do experiments in astronomy. But fortunately, the universe is so large that there are many, many different situations that we can study, and we can create a quite complete theory of how stars evolve and how galaxies evolve and how the universe evolves. To place this in relation to your own life and to what we experience as long. Is a year long? Yes, it's long for us, but not in the universe. The Earth moves around the sun, the Earth turns around its axis, and the moon goes around the Earth. There are a lot of ways that these motions affect our daily lives. It's not only that we plan our lives according to the sunrise and the sunset, that we make sure that we go out when we can see properly. It's not only that we sleep at night because we are built like that. Our biological bodies are also adapted to these astronomical events. We never chose it to be like this. This is what nature made us like. Everything around us somehow listens to this astronomical heartbeat. We are all part of this big universe. Time is around us and is governing us, and it all comes back to futile astronomical processes.